Welcome to PRUS Coding, and this is the AI networking course. And the first video of this course is the introduction to AI in networking. So let's get started. I have some sample code that this tutorial in this class and this course will be a hands-on learning course. So we'll be creating Python scripts. There will be packages that you'll have to download. So before we start, let's do some housekeeping. I want to start my terminal so we can get a good baseline of where we're going to start at. So I created a new terminal. I'm currently in my AI networking directory. Let's get started. So this is my AI network directory. We're going to look at the Python version that we currently are running on this device, which is a Mac Pro. And we're using Python 3.9.6. So anything 3.8 or above should be good to go. So let's get started. So the first package that we want to install, well, first we want to upgrade our pip. So we're going to do a pip install. We're going to do an upgrade if we have any. Check to see if we get any upgrades. Okay, cool. In my case, it's satisfied. Yours, you might have to do some, might download and do some upgrades. As soon as you get done with that, it should be good to go. Now we want to install NumPy. So NumPy is a numeric math library that is very well known. So you probably already have it. So we do NumPy. In this case, I've already installed it. The next package we need to install will be, there's 3 packages, so we can do it all in one. So let's be install. And then we're going to type in Scikit-Learn. And then we're going to do Scikit-Py. And then we're going to do the Matplotlib library. So in my case, I've already installed it. But as soon as I get done, then you can pause the video. As soon as I get done, you can start back and you can join us. All right. Now, since all the packages are installed for this particular example that I've created, let's go ahead and create a new directory. Let's just call it make directory introduction to AI in networking. Awesome. So we're going to change this directory. Let me hit clear. Awesome. So we're going to create a file. We're going to call this example.py. All right. And in our Explorer, we should see example.py. Awesome. So let's go ahead and get rid of our Explorer so we can get some more real estate so you guys can see. All right. Next thing, so the very first thing, we want to import our packages. So we're going to do NumPy as np. We're going to do import Matplotlib, and we're going to do the pyplot library, and then we're going to import. No, we're going to make this an alias as plt. All right, now we're going to import our machine learning, which is that Scikit. So we're going to do the Scikit-Learn. So we're going to do sklearn. And we're going to use the linear model, and we're going to import the linear regression. Awesome. All right. So now the next stage, since we imported and downloaded all of our packages, we want to create some sample data. So the data that we'll be creating, which will be a 2-dimensional array. The first one will be 3 positions in each segment. The first one will be the time of day. The second one will be the day of the week. And then the last will be the network traffic. These will all be numeric values. All right. So it'll be data equals NumPy. All right. We'll specify array. So this is the beginning of our 2nd dimension array. So we're going to do 8, which represents the day, the time of day. 1 represents the day of the week. And then, like we said, we're going to put in the traffic. Awesome. So just to walk through this code, so this will be 8 a.m. in the morning on Monday. We captured 100 megabytes traffic flow. Right. So we do 12 noon on a Tuesday. Captured 200. We got 16, which is 4 p.m. on a Wednesday. We captured 250. And we had 20, which represents 8 p.m. on a Thursday. And we captured 180. And then we had another one, which was 22, which is 10 o'clock on a Friday. 20. And then the last one will be 10 a.m. on Saturday, 150. All right. Awesome. Our sample array has a 2-dimensional array. 1 represents the first position, represents, again, the time of day. The second position represents the day of the week. And the last position will be the traffic, network traffic. All right, next, what we want to do is split our data. We want to split our data into 2 different features. One will represent the first plot we'll be pulling the first 2 positions of our array, and then we'll build another array, and then the second part we'll pull all of the network traffic in a separate array. So we're going to do X, and we're going to do data. We're going to create a new list, and we're going to specify we want to get everything except for the last position. All right, we're going to do Y. And we're going to do something similar, but we're going to create a new list, and we're going to get everything. We only want the last position. So again, just to put some more context in it, X represents 8 and 1, so the 0 and 1 position. So it's going to pull all of these, create one list, and then the Y is going to create and pull a list for all of our network traffic flow. Awesome. Now let's continue. The next thing we want to be able to do is we have to generate our model, right? So let's go ahead and instantiate our model. We're going to call this our linear regression model. Awesome. And now, since we instantiate it, we want to fit it with our data. So we're going to do a fit, and then we're going to pass in our X, and we're going to pass in our Y. All right, nice. So at this stage, we inputted our sample data into our model. And now what we want to do is we want to do some predictions. We want to say, hey, if at 3 o'clock on a Thursday, what it will look like. So what we're going to do is create a new variable called new data. We're going to get a NumPy array. It's a 2-dimensional array. So we're going to specify, let's do 14, which is 2 p.m. on a Wednesday. Awesome. And now we want to predict the traffic. So we're going to do predicted traffic. And we want to use the feature predict for our model. And then we're just going to pass in our new data. Awesome. Now, since we're predicting, it's going to analyze our sample data. It's going to predict an actual traffic for this particular model. So what we want to do is we want to print it. So let's go ahead and print. And what we want to add is we're going to create an F string and call this predicted traffic, network traffic. And then we want to specify predicted traffic. We're going to pull the first array of that because it's going to spit out a list. And this is going to be in megabytes per second. Awesome. Sweet. Sorry, let's get this up a little bit more. All right. Now, we want to do next is once we've done all of the, predicting a certain time of day, we specify what we want to predict at 2 p.m. on a Wednesday. Now we want to plot it. So we're going to use the Matplotlib library, and we're going to actually plot it, and so we can see the graph, like a graphic view of this. So we're going to do PLT, and we're going to do a scatter plot, and then what we want to do is we want to pass in the X, and then we want to pass in the first position. So we're going to get the whole list, and we just want the first position of that. We're going to use Y as our Y-axis. And then we want to make the color blue. And then we're going to give this a label. And we'll call this actual data. The next plot, let's do a plot, do the same X values. And we're going to do position 0. And then what we want to do is pass in the predicted model. So let's do the predicted. And then we're going to pass in X for that. And then we're going to change the color to red. We're going to give this a line width of 2, and then we're going to label this as regression line. Awesome. All right, so those are our two plots. So this should show a scatter plot of our original data, and then we're going to create a line graph for the plotted data for the regression line. All right, so now let's put some labels on it. So let's do the X label. We're going to call X label, call this time of day. We're going to do another one for Y label. This will be the network traffic. This will be megabits per second. We're going to specify the legend, so we're going to plot the legend for us. Okay. And then what we're going to do is we need a title. We'll specify the title as network traffic prediction with linear regression. And then we want to show this. Show. Awesome. Then we're going to hit save. Walk through this code again. So we pull in our packages, which is right here. We specified our data. This is our sample data that we put here. We split our data into two different separate arrays. The first one was pull the first two positions, which is the time of day, the day of the week. We specify our model for a linear regression model. We're going to fit it with the X and Y parameters. We're going to inject a prediction between 2 p.m. on a Wednesday. We're going to get the predicted traffic flow for that. We're then going to print it in our console, and then we're going to plot it with the scatter plot for the original data. We're going to plot the actual regression line, and then we're just going to label it. Okay, so everything looks good. I'm going to save this, and then what we're going to do is I'm going to run it for my console. All right, so this popped up on my other window, so please hold on right quick while I pull this up and drag this over. There we go. Sorry about that. And here is our line. So in our case, it's going to pull a traffic, predicted a traffic flow of 100, right under 180. And if we look at 2 p.m. 180, we're right under that 180. So that looks correct. And if we want to look at our plot points, so we have 8, 1 as 100. We have 10, which is the bottom one, a 6, so that represents 150, correct. We have another scatter plot for 12, which was 2, and it was at 200, and 16, which is around 250. And then we have this 22, which is around 220, that looks about right. And the last one, which is 24, which is 180 on the dot. Awesome. So, like I said, this is the first video. This is just the introduction. So we have a lot to learn, and thank you for joining.